seen in per capita terms, they suddenly appear extremely small, and then something where we are on top of the world, it will suddenly fall down at the bottom. And electricity is no exception. India is the 5th largest producer of electricity in the world, only after China, US, Japan and Russia. However, in per capita terms, India ranks around 150. See, this is from 5 to 150. China is at 80th rank, Russia 26th, Japan 19th, and US 11th. And that's the problem of equity that I think we need to address. Annual per capita electricity consumption, which is actually a key index for development. There are correlations, and I'm sure many of you are fully familiar with these correlations. Now in India, this is just at around 650 to 700 kilowatt hour per capita per year in India. Now, this is actually less than half of the average in non-OECD countries. If you remove the industrially advanced or rich countries and take the rest of the world, so it's essentially you're talking about the poor world. And you take average of the poor world, India is even half of that. So that's the situation. Seen in terms of overall global average, it is 1/4. And of course, if you look in terms of the OECD countries, the industrially advanced countries, it is 1/14. I suspect if you compare with US, we may be maybe 1/30. So that's the ground situation today. Here are some numbers. The population, the annual electricity generation, carbon dioxide emission, and annual per capita electricity. For the world as a whole, the OECD countries, the industrially advanced countries, and the rest of the world is non-OECD countries. And now, the average in OECD countries is around 9,000 kilowatt hour per capita. The average in non-OECD countries is around 1,500, which is twice of what we have, more than twice of what we have in India. 650 to 700 is what we have in India. So now, if you ask a question to ourselves as to what is the reasonable level of electricity availability, which in turn is a question as to what is the level of development, or what is the quality of life for an average individual in India that we should aim at. And I don't want to go into any more detail, but to say that there are various ways of looking at it. But if one reaches around 5,000 kilowatt hour per capita in the developing world, one can say that you can expect a reasonable standard of living for people across the world. But if you want to do that, then of course, I think it's unthinkable that you will levelize it by reducing it somewhere else which is higher. So wherever it is high, it will probably remain so. But where it is lower, if you say that all that will go up to 5,000 kilowatt hour per capita, it amounts to doubling the electricity production in the world. And today, the electricity production is at around 18.8 trillion kilowatt hours. We may have to produce something like 20 trillion kilowatt hours in addition. And all that has to go to these developing countries. And then one can say that, okay, everybody in the world can have roughly 5,000 kilowatt hour per capita, which is, so you have to double the energy supply in the world just on that account. There will be increase in the industrial advanced worlds inevitably, because that's where the growth takes place, that's where there is a capacity to pay. So I'm not counting that, I'm only talking about I'm not talking about the market dynamics, I'm only talking about the requirements, developmental imperatives. Seen in the context of India alone, if India alone we have to reach 5,000 kilowatt hour per capita, need to add additional electricity, which will correspond to 40% of the total global electricity produced. And I think we must recognize that that is, if you ask which country will require maximum electricity addition to reach that level, 5,000 kilowatt hour per capita, answer is India. It's not China, because China's per capita consumption is actually much above, but it may be around 4 times or 3.5 times India's. And so additional electricity that China would require to go to 5,000 is actually significantly lower compared to additional electricity that India would require. And that's many of us, even within the country, India, are perhaps not aware of this challenge. We know that we need lots of electricity, but I think we have to recognize that we need so much of electricity which constitutes 40% of so much of additional electricity which constitutes 40% of the global electricity supply today. And that's a major challenge. Now, we clearly cannot do this in a business as usual mode, because if you look at the carbon dioxide emission, which I think everybody is concerned, I know there are people who in fact argue that this perhaps is a bogey and that world will be able to manage equilibrium even with additional carbon dioxide emission. But I personally feel we can't afford to take those chances. You know, it's not a question of I think versus you think. If there is a risk, then I think we better start putting our act together to make sure that we don't go very close to the tipping point, because then it will become irreversible. And so clearly the energy mix in terms of supply of electricity has to change towards the non-fossil sources. And that's a major challenge. I'll come back to that. So I think we should look at the energy resources that one has in the country, in India, in that context. The table at the bottom here, it actually shows that what will be the depletion period for a given source of energy for a given rate of utilization. There are two rates. One is the current rate, where the electricity production in the country is around 700 terawatt hours, and the rate corresponding to 5,000 kilowatt hours per capita, as I mentioned earlier, and that will correspond to something like 8,000 terawatt hours. So I want you to focus attention on that bottommost line, the depletion rate, number of years for depletion at the enhanced rate commensurate with 5,000 kilowatt hour per capita, and you'll find all Indian energy resources start appearing very minuscule. Coal would not last more than 11-12 years at that rate of consumption. Hydrocarbon is actually negligible compared to that rate of consumption. Even uranium in once through use, that column shows uranium in PHWR, but and PHWRs are one of the most efficient technologies for uranium use. But even with that, it's not going to last more than a few months. And so it's important to recycle, because uranium you can recycle and get 50-60 times more energy. If you do that, then of course uranium can last for maybe 20 years. And that's where Indian nuclear program has been giving emphasis, because we have plenty of thorium in the country, and that can of course meet the energy requirements for a couple of hundred years. Even the renewables appear quite small. For example, the entire hydro potential of the country would appear to be just 5% of the total use at that point of time. It's important. We must make use of every bit of renewables, but that's the scale of the problem, which I think is more important to recognize. So the important renewable is of course solar energy. Solar energy can, for example, if you set aside something like 45,000 square kilometers, which is not difficult in a country like India, then we can in fact tap the entire energy that we require. And so the long-term imperative for the energy challenge in India is number one, thorium, and number two, solar energy. I'll come to solar towards the end. But again, staying on course with nuclear energy, so that was the basis for the three-stage nuclear program in India, which I'm sure many of you have heard. It's a step-by-step development of the technology so that we can go up to thorium. Step one, set up reactors which would run on uranium. And in India we have chosen to develop the heavy water reactors. And that's because number one, as I said, this is the most efficient utilizer of uranium compared to any other reactor system. And number two, from the point of view of self-reliance, achieving self-reliance, at that point it was considered that it would be within the industrial capacity of India at that time when the program was set up to develop PHWRs, which has been actually done. And for now more than a decade, Indian PHWRs have been demonstrating world-class performance. In fact, some of the PHWRs have been recognized to be the best performers in the world by World Association of Nuclear Operators. They've been given awards, not I think more than twice. So it's a kind of it's a performance which matches the best benchmarks world over. There are 18 such units operating in the country, all built through self-reliant mode, and 4 more are under construction, and several others are planned. There are 2 boiling water reactors in India, but that's where the reactor or the nuclear energy programs began. These 2 reactors were set up as a turnkey projects by General Electric. Actually, the Indian program actually began with a cooperation with US. And they are still operating well. They have been refurbished and they have been looked at by international groups. There are 2,000 megawatts VVRs under construction, fairly advanced. I think one of them may go on stream this year. And then, because we now have this international civil nuclear cooperation, one can expect a significant number of light water reactors to be constructed. So this is the first stage, and if you recognize world over, the reactors are essentially of that kind. We would make use of uranium, either natural or low enriched, and set up reactors, and that's the mainstay of the nuclear program worldwide. And we are quite there. Only thing is our capacities are small. All put together, this will add to something like 5,000 megawatts now, which is actually less, it's around 3%